Hey, hello there. We're going to take a look at the 5 break-even analysis practice problems that are part of this course. And what we're going to do is, even though this is an online activity, what we're going to do is try to approximate what you'd get if we were back in a classroom as a group. So what I've done is I put together these 5 break-even point problems so that if you can master these, you can master the stuff that's on the quizzes, and the quizzes usually end up on exams. In fact, one of the secrets is that often last time around's exam questions get rotated into the quiz category. So these are terribly important. What I like about break-even analysis is it gives you a very good first approximation as to what your likely chances are for success. So that's what we're going to do. Let's take a look at this make-believe situation of Atherton Foods, and I've kept it very simple and tried to follow the same kind of symbols, etc., that you see in the textbook. But sometimes if you can follow it through, and I'll have my finger as if we're writing on the board. Okay, we're trying to figure out if we want to enter a new market. Market research with a new product. Market research says that we could sell 10,000 pallets of canned corn in this new market. If each of the pallets sells for $100 and the average variable cost per pallet is $60, and to supply that market we must buy warehouse space, have fixed costs of $200,000. The first thing we want to know is what is the break-even point in pallets, because you need to be able to do both of these things in both dollars and pallets. And so let's deal with our first equation. And you've seen the derivation of this equation in the textbook. So in our case, it's the total fixed cost, TFC, divided by price minus average variable cost, AVC. And price minus average variable cost is our contribution. So what we've really talked about here, and what we would get if we did this in class, is to pay off $200,000 of fixed cost, how many units do we need to sell where each one, after they've paid the variable cost, has $40 to help chip into the $200,000 fixed? And the answer, as you can see down here, is 5,000 pallets. So they must sell 5,000 pallets to break even. 5,000 pallets, each contributing $40 contribution to overhead and fixed costs, equals our $200,000. There we go. There's our first one. Not hard at all. The second equation is sometimes we want to do this very same calculation in terms of dollar sales rather than in units. And we see there are times when that is more advantageous to us. So what we do is we have to modify, as we did in the book. We do the same problem, and we're going to do is convert everything to percentages. And to keep it simple so the math doesn't get in the way, we've kept the price at 100, and we've split the variable cost, etc., out as percentages. Now we have a modified formula, same one in the book. Break-even point with the dollar sign, which is dollar sales, equals total fixed cost divided by the contribution margin percentage. And that contribution margin percentage comes from what percent of the selling price, because we measure everything off of selling price, of each dollar sales, what percentage of that goes towards paying off our fixed costs. So we insert that 0.4 in the denominator, and now we divide the 200,000 by that, and we end up with sales. They must have sales of $5 million. Well, interestingly enough, if we take the $5 million in dollar sales and divide it by the $100 per pallet, we're back at the same number we had before, 5,000 pallets. So either way, we'll get you there. Now we start to make things a little bit more interesting. Some of the other test problems that are on this course site, you'll see, I think there's one with a school superintendent who gets to try out different pricing for lunches. It's a quick way to do things on the back of an envelope. Let's say the firm decides that it's not going into this market unless it can make a 15% profit on sales. Now, to reach that goal, how many pallets do they have to sell now if they have to include this 15%? Again, we modify the equation in 2, where we take total fixed costs divided by the contribution margin percentage, minusing the 15% profit. So we end up with where we are here. Now we learn that sales have to be $800,000 for the firm to earn the 15% of sales. Well, lo and behold, let's see if this actually worked. Well, with $800,000 at $100 per pallet, that's 8,000 pallets. Let's work our profit equation again. And when we get all done, we end up with a profit of $120,000, which, surprise, surprise, is 15% of the $800,000 sales. And again, 8,000 pallets. So this tells us that if we're mandated for the 15% profit, then we've got a significant jump in the price. In today's more accountable world, and what am I getting for this kind of expenditure thing? One of the things you need to evaluate is a change in total fixed cost. And one of the most common things we keep running across with our industry buddies, hey, we spent all this money on advertising, and did we get anything for it? Are we making money? We spent this money on advertising. How much did sales go up? And so on and so forth. So again, we return to the thing in the book. And in this case, we only have to measure up here in the numerator the change in the total fixed cost. Now, in this case, we've put together this thing with $50,000 in advertising, and we put that in the numerator, divide it by the 0.4 underneath, and we end up with $125,000. So this means we have to sell 1,250 more pallets for us to repay the cost of the advertising. If we don't sell that, we didn't break even. We lost money on our advertising. And lo and behold, when we go back and test all this by taking the original, the advertising, we'll circle this. In fact, that's exactly what happened, because we had to increase sales from 500,000 to 625 to pay for the advertising. Very simple, very straightforward. Very powerful tool to help us figure out this is not the end all, but it's a good place to start. It tells you whether it's worth doing more serious analysis. All right, this last one, for those of you that are going to check, is this has been a little bit more common. People have struggled with this more than anything else. We want to figure out what is the selling price. Because if you remember in the text, we had a triangle. And we had cost, prices, and quantities. If we know 2 of the corners of the triangle, we can find the 3rd one. So we're going to say is, okay, if we sold the $10,000 10,000 pallets that we expected, what is the price that's compatible with that to give us break even at 10,000 pallets? Well, let's go back and start with our original equation. Total fixed cost divided by price minus average variable cost. We want to reshuffle the parts, and I'll let you work out the intermediate steps. And it's just like what you did in high school algebra. Train leaves town A and all that kind of stuff. So we rearrange it so we end up solving for P. First in, 200,000 for the fixed cost, the 10,000 units. So we have an average fixed cost of $20 plus an average variable cost of $60 means the appropriate selling price is $80. Let's see if that worked. And again, we can get in there and look at that profit equation and find out that when you do in fact sell 10,000 units, the profits are in fact 0. So $80 is compatible. So what we've got here is very simple things. Make sure you look at those cautions at the end of the break-even point. But I used to always use the example in class. You come into a market and you only have to sell 300 units a year to break even, and you think you can sell thousands, that's good. But if you have to sell thousands and you think you may just sell a handful, no sense doing anything more complicated. So within its limits, it's a good first test. I hope this helps. Talk soon.